Welcome back to TSC lecture. In this lecture, we're gonna learn how to convert a regular expression into NFA. So we already know there's a connection between regular expression because regular expression are recognized by some regular languages. So definitely we can build a corresponding NFA from the given regular expression. Before we start, we need to know some building blocks. That is how we gonna convert regular expression to some corresponding NFA step by step. So there are 4 types of blocks available. First, for any basic types of regular expression, suppose A or B, we are gonna use these types of transition. Now, if there are regular expression of type R1 plus R2, we are gonna have this type of parallel edges between start and final stage. We can see that to do so, we can have transition having lambda input symbol. Then another type of transition for concatenation, R1 then R2. So first we draw the transition diagram for R1 then R2 by this series. Then we can have a regular expression of closure. So in that case, this whole loop can be repeated again and again. Sorry. So this kind of closure operation can be repeated. All types of regular conversion of regular expression to NFA will follow one of these steps. Let's start with an example, very simple example. In this example, for regular language A and A B B of 2 strings, and then the next example B B B B A, that is any string either lambda or having A started with a single B. So for the first solution, we start with building block A. So we just take an edge and write whole regular expression over here. So next we break this transition into 2 parts. That is for, we can think that is R1 and it is R2. So we have parallel edges here, 2 edges, and the next the edge below contains the 2 string because we haven't break it down yet. The last step we actually separated VB using another state. So I left this state names blank. You can put any names here. So this is the first example. For the second example, the regular expression for the language, corresponding language, is B A star plus lambda. So we write down as before like this. Then since it is a plus symbol here, so we have parallel edges. And the next step, the third step, we break it like B, then A star is edge and lambda as well. So this A is a closure operation. So we get the state here and draw a self edge so that we get it like this. So at the final step we get the NFA like this. A second example is a tricky one. So if a regular expression is given, the complex regular expression, we write it accordingly like this. So in step 2, this is a R1 R2 concatenation of, this is R1 R2 concatenation. So write to any series from no parallel edges. So this is R1, this is R2. The third step, we break the first R1. So we start with the lambda, then since it is star closure, so we have to self loop for the state A plus BB, and then taking a lambda transition, go to some next state. Then this is for R2 B A star. So one edge comes as B, taking input A, and for closure A self loop is here. Then a lambda transition, go to final state. Then again for this R2 can be broke as R2 dash and R1 dash, like this is something like R3 R4. So we have parallel edges for lambda here. Now the next step, step 4, we have to break this transition. So since it is a plus sign, it's a parallel edges like this, A and BB, and finally we break the state for the string BB. So we get this and this. So this is our final conversion of the corresponding regular expression. So you can see while we have final transition diagram, these types of diagram, we may encounter different edges of with lambda transition. So this lambda transition can be removed, which is also discussed in previous lecture. The link for the corresponding lecture will be given in the description block. Now comes the next important, the next thing. Now if we are given at NFA, then how we get a regular expression for the corresponding NFA. So to start with that, this is not so simple as we did in conversion from regular expression to NFA. To have a regular expression from an NFA, NFA to regular expression. So for that we have to use extended algebraic expression of RS method, which is previously discussed in the first lecture of regular expression. Before using that RN methods, we have to have some assumption to apply RS method. First thing is that the transition graph, the first method states that transition shouldn't have any lambda transition. It should have only one start state, and we can do a note, remark, or anything named the state as v1 to vn. So the regular expression will be dictated whatever the regular expression we obtain for the final state vi, and to start with that we need to build some equation using the transition and the states given to the NFA. So we have Vn. So each Vi actually describes the corresponding state, and alpha ij is input, the transition that comes to the corresponding state. So after getting all these equation, we apply RS method repeatedly, and finally we sum of all these results to get the final regular expression. For example, this is a given regular expression. We have to find the NFA. We have to find corresponding regular expression. So according to our assumption, there is no lambda transition. So and you want initial state here, so we can use the extended version of RN method. For this NFA, we have three equations for each state: Q1, Q2, and Q3. For Q1, the input symbols are A. Okay. For Q1 gets to, for taking input A, so we get Q1 A. Then taking B, it comes to Q1 from Q2, so Q2B, and then lambda, because this start state comes to this state without taking anything, so lambda is used here. For Q2, a transition comes with input symbol A from Q1, so Q1 is here. Then taking a B goes to itself, so Q2B. Then again a transition comes from Q3 with input symbol A, so Q3A. For the Q3, only one transition comes to Q3, so from Q2 with A, so there's only one term in the equation. Now the main thing, we have to solve this equation by replacing method. So in Q2 we can see the Q3, so Q3 is a Q2A, so Q3 can be replaced with Q2A, so this becomes Q2 becomes this, finally replacing Q3, and using Arden's theorem we get this. And if anyone forget about what is the Arden theorem, it states that if R equals to Q plus RP, then the solution for this equation R equal to QP star. So we have used this that theorem to get the result. Now Q2 is the result for the Q2 is obtained. So Q2 is replaced in Q1. So Q2 replace Q1 like this, lambda. We take Q1 outside, we get this, then lambda. So using again Arden's theorem, we get the solution for Q1. So finally we have to apply this Q1 to Q2, so get the final regular expression for Q2. So we obtain this. Now in the last equation we have to replace Q2, so we finally obtain this regular expression. This is the result for the corresponding NFA. So this is how we gonna use if we want to convert some NFA to some regular expression. Thank you very much.